Okay, where is it streaming though? Let me. Okay, it says sending data, so should come up soon, I think. Okay, now it says streaming.
Yes, we're live.
Okay, you can see us, right? Because I don't see us yet. Yeah, we're live.
Yes, we are.
Okay, I guess then. Hi everyone, welcome to GraalVM 22.3 release stream. My name is Alina, and here with me is also Thomas Wirtinger. Hi, Thomas.
Hey.
And Fabio Niebhaus from our team.
Hi, Alina.
Hi. And yes, we will talk about with you what's new and cool in GraalVM 20.3. So as always, you can ask us questions in YouTube chat, and we will try answering them as soon as we see them. Okay, I see some comments coming up, so this is looking good. So yes, today we are releasing 22.3, and let me get our release blog post, which we published a few minutes ago, to show you what is new in this release. Okay, this should be all right. Yeah, I see some delay on my end, but I assume this is showing. Okay. So yes, today we are releasing 22.3. We have a lot of new and exciting features in this release, and we will talk about them in a second. But also, besides those features, I want to mention that 22.3, as the last release of the year, will keep receiving updates for the next 12 months. So if you were considering what is a good moment to upgrade your GraalVM version, now is a good time to do so. And as always, you can get our builds from GitHub for Community Edition, from Oracle Technology Network for GraalVM Enterprise, and we will talk about all of that in a second. But before we talk specifically about 20.3 features in this release, we want to mention one more important recent update that I assume a lot of you are curious about. So last week at Java 1, it was announced that GraalVM will become a part of OpenJDK. And what this means is that GraalVM's Community Edition Graal compiler and native image will become a part of OpenJDK. And this, I think this change will be very exciting and very important for all of our GraalVM community, but also for the wider Java ecosystem as well. And in practice, what this means that we will adopt the same methodologies and approach that the OpenJDK team and community are using. So we will also have committer and reviewer roles. We will have JABs. And another important update is that we will also align our release model. So we will also have critical patch updates releases every 3 months, feature releases every 6 months, and an LTS release every 2 years. And we actually prepared an announcement for you about this change that will go up on our website anytime now. But before we look at that, Thomas, Fabio, is there something you wanted to talk about this?
Yeah, I mean, I think we will soon put up an FAQ about this publicly. So there's details available, and yeah, we are excited that we can for the compiler and for native image now become a part of the OpenJDK community. Important to note also is that for other components related to GraalVM, like Truffle and the languages like Python, Ruby, etc., they will continue to be developed as is. And we will also, for the foreseeable future, have a GraalVM distribution that will contain all of the components like previously. The only major change there is the release schedule, which will be adjusted from the 3 months to the 6 months. And with that also, it will be simpler because there will be one GraalVM version for one specific Java version. So you will be able to have to say that, yes, this is the GraalVM version for Java 20, or this is the GraalVM version for Java 21.
Okay, thank you, Thomas. And I don't see any questions about this at the moment, but if you have any, you can ask us throughout the stream. Okay.
Well, actually, it turns out, Alina, our website just got updated. So the announcement is now up. I think you can pull it up if you like.
Let's give it a try. Yes, I'm linking to it somewhere here. Oh, not for me, at least, I think.
Well, you have to
Yeah,
refresh
let's revisit
tab,
this
but
at the end of the stream, maybe.
Yeah, let's give it another try in a bit. But yes, this announcement will be up, and it will hopefully cover the rest of the questions that you might have. Okay, let's talk about 22.3. So the first thing I want to mention is that now we have GraalVM JDK 19 builds. Okay, am I screen sharing? Yeah, okay.
Yes.
So now we have JDK 19 builds. You could have tried our JDK 19 builds before when we released them as developer builds, but now we actually have our normal regular builds, and that means that you have access to all of the GraalVM components on JDK 19, so the GraalVM compiler, native image languages, except just for Java on Truffle. So you can use all of our components, and you can also use all the latest Java features that are in 19. And as an example, you can use, for example, virtual threads from Project Loom. You just have, if you want to do this in native, so it does work with GraalVM native image, but if you want to use it in the native image mode, you would have to add this enable preview option in your build file, since this is a preview feature. And as an example here, to show you how you can use this on GraalVM and specifically with native image, we have this game of life demo running on GraalVM JIT and on GraalVM native image. And let's see if I can get it any closer. So here our app is doing some extensive computation, and also I believe it's running 16K virtual threads. And here on right, it's our native image demo, and you can see that it's performing faster. So it starts faster as GraalVM native image.
yeah, this is just about startup, right? So, of course, Peak is also doing pretty well. We are still interested in benchmark numbers, and we're benchmarking this on our own, right? So, some microservice frameworks are already playing around with virtual thread support. Like there's Helidon Nima, and I think even the Micronaut folks are working on virtual thread support as we speak. So once this is ready to show, it would be great to get some numbers from them. So yeah, if there's a performance problem, for instance, that we can address. But so far, it's looking pretty good. Of course, this is a toy example, but it's also kind of fun. I think Peter and the team has done a fantastic job implementing virtual threads in native image, and I'm very glad we can show this off today.
Yeah, thanks again to Peter and the team. And so we encourage you to give our JDK 19 builds a try. One thing we want to mention is in this release of GraalVM, JDK 19 is still experimental. We are planning to make it supported in our next releases, and also talking about specifically virtual threads. So they are not yet supported for GraalVM languages, so languages such as JavaScript and Python when runtime compilation is enabled. But other than that, everything is working. So take our JDK 19 builds for a spin and let us know what you think. So that is one change that we want to talk with you about. And another one is a new exciting way to easily download GraalVM JDK. So as you probably know, before you could download our JDK from GitHub, from Oracle Technology Network, you could use our GitHub action, VS Code extensions, SDK man, a lot of ways to do so. But also we are adding this brand new way where you can download GraalVM JDK with this one-line command. And it also includes native image. So basically with this one command, you can get the full GraalVM JDK and native image and start developing your apps on GraalVM. And for that specifically, we will also have a separate blog post that is already up. So this is from Fabio, where you can read more about it and how this command can be customized and what else you can do with it. But also we want to show you how to use it in practice. Let me just go back here. So this is my one-line command to download JDK, and I can copy it and try installing it here. So if I run this command, it will download, it will use some selected defaults. So right now, if I run this, it will download GraalVM 22.3, the latest release, and the latest supported version, which at the moment is Java 17. But you can also customize it, and you can read about it more in our blog post. So let's say I don't want to do 17, maybe I want to get 19. So let's try doing it. So GraalVM EE.
Yeah. So one thing to note is you're trying to download Enterprise here, and that only works if you have a token. So if you're trying to do this and there is no token, this script will actually help you set one up. We just need you to confirm the license, and then you can install it and reuse the token on your build machine, for instance. But yeah, so that's the build output, and it's relatively simple, right?
Yeah, and it's also pretty neat that if I previously used Enterprise on this machine and I already have my token, right, it will automatically figure it out and not ask me for any more input or configuration, just would automatically get me the builds.
Yeah, you can just run it again, and it will just tell you it's already here.
Let's do it. Yes. So it says that GraalVM JDK already exists in this current destination. And it also shows me some helpful information. So for example, this it shows me that if I want to make sure that native image would work, here are some prerequisites for it. Or for example, on a Mac machine, it would help you figure out the quarantine for the binaries. So now I have my GraalVM JDK downloaded. And let me also set it up. So I would have to run those few commands.
Yeah. You can run those manually, but if you are an SDKman user, a little bit further up, there's also an SDKman installation line that you can copy and paste to register this local installation in your SDKman, so you can easily switch between Java versions and GraalVM versions, of course. So you've done it the manual way, and now that you've adjusted your path, we can actually see that Java now points to the new GraalVM release Enterprise.
Yeah, and let's just verify that I also have native image here. Yeah, GraalVM 20.3, Java 19, all looking good.
Yeah, and if you're wondering what's behind the curtain, well, this is actually really simple. We don't do anything fancy here. All of this is public on GitHub. You can look at the script. You can contribute to the script. You can also download the script before you actually want to evaluate it, in case you're curious what's happening there. And of course, you can run with --help, and then see what this thing can do as well. By default, it will just download the JDK into the current working directory, but you can also use --2, for instance, to specify a specific directory, or -component, component, or -C short to install other GraalVM components such as Python or Ruby if you want. Yeah, and it works on macOS, Windows, and Linux. On Windows, you have to use Git Bash, Cygwin, or Windows Subsystem. For Linux, well, Windows users should be familiar with this if they've used SDKman. Works just the same way. And I hope this will make GraalVM installations much more easier.
Thanks, Fabio. Yeah, I think so too. So that is our new one-line JDK downloads for GraalVM. And let's talk about some other cool features of this release. So as you know, there is this JWeb server tool, which is available as of Java 18. And now since we have JDK 19 builds, you can run it with GraalVM as well. And what is the coolest thing? You can also compile it to a native executable using GraalVM native image. And I believe we will show it to you later on when we will show some demos for native image. But also you can do this on your own by using this command we are sharing with you here. So that is that. And we have this whole section of updates related to native image monitoring and developer experience. Fabio, do you want to talk about this one?
Yeah, sure. So there's lots of things going on in the native image DevX and monitoring world, if you will. So one thing that we are introducing in this release is a public API, enable monitoring, that you can use to enable heap dumps, JFR, JVM stat at the moment selectively. You can also just say all, or by default, if you're leaving the argument out, and just use enable monitoring. then it will enable all for you. That's essentially what Allow VM Inspection did previously. That is a private API, which has now been deprecated, so we don't encourage you to use this anymore. It will go away at some point, but now you have fine-grained control over what type of monitoring service you want to ship within your native executables. One thing that you may have noticed is JVM stat is new in this list in community. So with JVM stat, you can monitor your executable. Of course, it will slightly increase your image, your native executable or shared library, but in return, you get monitoring capabilities. And as I'll show you in just a bit, you can also use this to even take heap dumps from within Visual VM interactively. Together with Red Hat, we've been working on extending JFR support. So there's new support for different JFR events, such as Java monitor enter, wait, or thread sleep. And together with them, we are also working on a better debugging experience. And one of the things that Red Hat and the team around Andrew Din has contributed is initial support for perf. So you can use perf the info in draft, stored in draft, to essentially sample your and profile your application. Another thing that we've done, this is again just a bit more cosmetic nature. You may have heard of our SBOM integration, software bill of material. We now provide that as a public API, ---- enable SBOM is the option. And last but not least, we've further decreased the installable size. So when you install the GraalVM JDK, you're actually downloading the JDK and then install native image. And this native image installable is now around 30 megabytes in size. It was previously 120 megabytes in size. Well, how can we shrink this so much? Well, it turns out we have shipped our LLVM backend with it. And we're not doing this anymore because this is not the very common use case. So if you were depending on the LLVM backend, you were using that. You have previously ran something like install LLVM toolchain. Instead of that, now just run a native image LLVM backend, and you're good to go. So it's the same amount of work for you if you're using the LLVM backend, and the majority of users they just benefit from fewer bits to download, I guess. So with that, maybe it's time that I do a quick demo, right, of this. Let's see whether this is actually quick, but let's take a look. So one thing that we now have is JDK 19 support, and I have prepared some scripts here. We'll actually get to see what they do. So this is the JWeb server running. It's this new tool that comes with Java 18, and since we now have 19 builds, I can just run it from within here. It just lists what's currently in my working directory. It's like a dev tool. So here you can actually see the script that I just ran and some other files that are in here. So it's a really simple service. So of course, you can just run it like this. And then what we can do is we can connect or open up Visual VM and then look at the process, right? So here we get like monitoring. We can look at the heap and heap usage. We can look at threads and so forth and start sampling and whatnot. So let me kill that process real quick. And one thing that we've also been working on is JLink support. So previously, when you build a JLink image with the GraalVM JDK, you unfortunately ended up with C2 as the tier compiler, the top tier compiler, and now that has been fixed. So what I can do is I can run JLink build, which builds me a JLink image. So this is the command that does this, and essentially I'm building a minified version of what I need to run, of the JDK, what I need to run for the JWeb server. So what we end up with is a JLink directory, JLink JWeb server directory, or JWeb server JLink directory, I guess, JWeb server JLink directory. And then he has a bin directory, and this bin directory essentially only contains Java, JWeb Server, and key tools, so nothing else. So this is like a stripped down version. I don't know how big it is from the top of my head, but this is how you would deploy it if JWeb Server is like a really simple thing that you want to deploy. So of course you can run this, and when I run this, I can again like open the URL, but I can also open this up in GraalVM. So what's interesting here is if you compare this, it says the JVM doesn't support the CPU view, and all of a sudden the thread tab is gone. So this is really a stripped down version, right? So I have removed, while I was building this image, I've removed this additional capability because I may have decided I don't need it and I want a really small JLink image, right? So, of course, this is just one thing that we wanted to show. So JLink is now supported. And I forgot to mention, of course, so now if you look back at this thing actually has, the image actually runs the Graal compiler, so in a thread. This is now using the Graal compiler as opposed to C2 previously. So the next thing that I want to show is we can, of course, build a native image of the JWeb server now. So what I can do is I can go and use the new release. So, and I would use a native image, and then I would do JDK HTTP server.
Can you move the console a little up? Yes, exactly.
Yeah, of course.
It's actually good. It's good. No, it's good. Alina just fixed it.
Okay. I don't know how she fixed it, but thanks, Alina.
I changed the layout, so it'll good.
Okay. Okay. There you go. So so here I am. I can do minus module and then JDK HTTP server, and well, of course, we want to take the new monitoring API for spin. So I also add enable monitoring. So yeah, that's better. So that will essentially, so in this directory, there's no source code, right? So this is building a JWeb server. I forgot, I can also change the file output name. So let's call it JWeb server. So this is building this JWeb server binary now, just from the code in the JDK, using the JDK HTTP server module in which the JWeb server lives. And it's picking up automatically the main entry point because that's the main entry point associated with that module. So if I replace native image with just Java, that would be one way to run the JWeb server on the JVM. But here we're building a native image, and you get to see the usual build output. So when this is done, shouldn't take too long, we can run it. Well, let's see. Yep. My computer is busy streaming and building native images at the same time. So here we go. So I can run the JWeb server, and works the same way. So I get this URL, I can click on it, and I can look at the file directory. Right? I have prepared a bunch of different versions of this JWeb server already, as you may have seen. So let's take them for a quick. Let's do a quick benchmark, actually. So first of all, what I'm going to do is I run the JLink version. Hang on. No, I do JIT and I run just the JIT version. So this is the normal JWeb server thing. So let's open it back up in GraalVM, and let's look at the graph. So this is not doing much. We are using 8 megabytes of RAM and 30 megabytes in total. So I have this little tool here called Hey, which allows me to send 10,000 requests to the server. And when I do this, you can see that memory consumption increases, and there's some CPU load, and then we get a result. So this thing actually tells me, okay, JWeb server ran, and here we ran with the Java version of this thing. on the JIT, right? And it will tell me something like 3,480 requests per second, 42 milliseconds in response time. Well, that was at least the majority of the requests, and 10,000 responses in total. So I have the same thing here, but in native, and I'm running this with PGO. So with PGO, the web server runs, and here I can fire up the same thing. But before I do this, let's connect. So this is actually a new process showing up in here because I compiled it with enable monitoring and JVM status there. So this tells me here's substrate VM. So this is now our VM components, our GC, and so forth. And I can click on monitoring. And now we can see here is the actual heap size, 7.3 megabytes. And I can fire up those requests. And we can see how the process behaves. And what you may have noticed is that CPU usage is fairly small, and the GC usage has actually decreased afterwards after the load because we have the way the serial GC works here. Well, sometimes you see a little spike like here. That's when the load came in, but so far this is now using fewer memory than the process used before. So let me kill this one real quick, and let's look at the numbers. So on the right is JIT, and JIT had something like 3,400 requests, 3,480, and here we are with more than 4K, and the response time is actually just 9 milliseconds in most of the cases. So these are probably due to the GC. So yes, of course I can rerun this, and we can use different GC. This time I'm using G1. So, and here's the new process. If we start monitoring, it actually reports 0 because there's no load on this thing yet. So let's send the same amount of requests again. And now you may notice, oh, this is like a lot of memory has been allocated, and G1 is doing a lot of things, right, compared with the JVM. So if we actually go back to the JVM mode, we can see that the JWeb server is actually started with XMS 8 megabytes. So this means the initial heap size is limited to 8 megabytes. So to be fair, right, we should do the same here. So I can do this and rerun the server, and then here's a new process. And this now, let's see, this now looks much more similar to what you've seen on the JVM. So, but still, the requests are 8 milliseconds compared to 42 milliseconds on the JIT, right? And if we compared the two, native versus JIT, well, let's see, I can stop this. No, I can't, but this is the serial GC, and here is the JVM mode. So afterwards, the JVM had a used heap of 9 megabytes and 75 megabytes allocated. And here we are with 20 megabytes, but only 40 megabytes allocated. Of course, I can might be able to trigger a GC, not here, but I can do one by taking a heap dump, because the heap dump actually triggers a GC.
Can I click on permgen here for a second? What does permgen say on
permgen doesn't report anything at the moment.
Also not on JVM mode?
On JVM mode, there's just metaspace.
Yes, exactly. Because one thing to note, of course, is that like we don't have metaspace data, so this is kind of overhead for the JIT mode that we do not need in the EOT mode.
Yes, exactly.
And when we say here heap or heap size, it's only the Java heap. It doesn't report really the process RSS size.
Yeah.
So the total memory consumption of the process.
Yeah. So what I've just done here is take a heap dump from within GraalVM of this native process, right? So if you look at this again, this is substrate VM and this is a heap dump. So, and maybe this was a little bit too quick, but for the sake of the time of this live stream, we have to be a little quick. But you may have noticed there's not much difference between running in JIT and running on native, and that's actually what we want to achieve, right? So what we are aiming for is providing as close as we can get JFR support and even JMX support. We're working on that with Red Hat also, and we may have an update on JMX support in the next release. So yeah, so in the end, we want to enable you to be able to use your native executables as a drop-in replacement for your JVM deployments.
Right. Yeah. And does the JVM get faster if you give it 1 million requests? Like, can we try that for a second? You give it how many requests did you give it? 10,000, I think, right?
Yeah, 10,000. So what you want to do is you want to run JIT versus. Okay,
let's just run JIT with, let's just give it more requests. Let's see where it stands. So here we had about 8 milliseconds per request. We already know
yeah, that. But also, like, in terms of throughput, I think on 10K, native image was faster, right? When we were comparing requests.
Yeah, on 10K, it's certainly faster, right? The question is it still faster on 100K, on 1 million, right? So there's like the point where the JIT is starting to overtake. And I mean, it's clear that, like, if you have a relatively low load, it's a no-brainer to use native image because it will always be faster.
Now my terminal has broken. Let's see.
Right.
How many zeros do I need to add? So now it's 100,000.
Okay.
So and I added def null so that the terminal doesn't add any output, any overhead. Right. Let's see. I think this takes around 15 seconds, I hope.
Right.
Okay, so this is 100,000. So, and here we are, well, I have to kill this one, and then we start with this. We start with the same settings.
Yes.
So here is the native version of this, and we.
Right.
Yeah, apologies, my terminal doesn't like this. Let's see. I hope this works, or at least it doesn't complain. So here we go with 5,100. Yeah, it's slightly better.
Right. Yes.
But the response time is still not on the same level.
Yeah, and yeah, but in general, like, if you go like to 100,000 or 1 million requests, then it's still like the JIT can still pull ahead. At least in this example, not always. It depends. It depends on the application, but the difference is certainly smaller. But if you have something that is not serving millions of requests, it's a no-brainer to do ahead of time compilation. We are trying to make sure that in the future you will have, even if you have long running, you can use EOT mode without having any throughput degradations. And yeah, I mean, this is obviously not the best, benchmark setup, etc. But in general, yeah, it's if you have a very long amount of requests, they are currently in the same ballpark. If you have small amounts of requests, EOT is clearly ahead.
Yep. So, Alina, what do you think? Are there any comments in the chat? Just a few things that need some cleanup,
I think it was mostly me and Thomas, but let's give people some more time to come up with questions.
Yeah, well, otherwise, go have a look at the release blog post. That's also where we mention how to build the JWeb server, native version of it, and then give this a go. And feel free to let us know how it goes.
Awesome. Thanks, Fabio. Let me get back my screen. So while you were demoing, I also got the updated link for the announcements. So we wanted to show you this announcement page, which is very nice, thanks to our awesome team. And here you can read more about this contributing GraalVM community addition to OpenJDK, and also there is an FAQ answer for some common questions. So this is on the website, and we also link into this from the release blog post, so you will be able to find and read more about it. So there is that, and let's go to the release blog post. So what else is new? We talked about monitoring and developer updates in native image. Another thing related to native image as well is that we released a new version of our native build tools. That is the Maven and Gradle plugin from our team. So if you haven't updated, please update now. And also we released, since the last time we talked about 20.2, we released a few new versions of GraalVM reachability metadata. So when you go there and you look at the metadata, you can see that this repo keeps growing. More and more metadata is getting added here by our team and by our community members. So thanks a lot for that. And also make sure you update to the latest release of GraalVM reachability metadata as well. So there is that. And another change in native image is that we now have a bunch of new native image APIs. For example, for library and framework authors, we now have APIs for programmatic registration of GNI resources, proxies, serialization from the feature classes. And we also moved annotations for method substitutions to the Graal SDK. So for this release, 20.3, we will still publish the SVM artifact on Maven. That is the artifact that is giving access to native image internals, but we suggest that you move to using those features from GraalVM SDK instead. And if you think there are any APIs or features that are missing, please report to us and we will work on that. So I think that is all that we had for native image updates, unless there are some questions.
There is actually a question. Let me pull this one up. So did I see correct that you were inspecting a native image build app with Visual VM Live? Yes, that is correct. And yeah, this is new in Community Edition. It shows because it shows in Visual VM when you build with JVM stat. So for that, you need to enable monitoring, right? And it was previously only possible with Enterprise. So now this is also available in Community Edition for everyone. In fact, it also works for our GraalVM language runtimes like GraalPy. They also show up in Visual VM, even though they're compiled to native.
Awesome. Thank you, Fabio. And I don't think we have any more questions, so we can move on to compiler updates. So as you mentioned, we now have JDK 19 builds, and it means that you can use all the latest Java features now on GraalVM as well. Now, another change that is specific to GraalVM compiler is that we are now using one isolate per compiler thread. And this means better isolation and also less GC for the compiler, which in turn ends up in better compilation throughput and memory footprint. And we saw a bunch of improvements across a wide range of benchmarks for this change. And this is now enabled by default. If for some reason you want to disable this change, you can do this by using the following flags that we see here. And also we added a dedicated native image GC policy that is supposed to minimize RSS memory usage, and this is also enabled by default. And we also mentioning here that JLink now works correctly with GraalVM, so this is something we also showed previously in our demo. And talking about other compiler updates, we also implemented loop vectorization for integer min and max operations. So for code pieces like the one we see here in the blog post, we should get something about 8x faster. And this is also enabled by default, as well as some of the optimizations that we introduced in 20.2 and now are enabled by default as well. So this is it for native image and compiler. And another
exciting. We got a few questions now, I think.
Yes, let me pull one up. So let's start with this one. Is it totally fine to use native image for long-running applications? What do you think, Thomas?
Oh, that's a great question.
Yeah, so it depends on the workload. And also it depends on whether you have access to Enterprise with G1 GC or not. So in a long-running application that requires that GC is a factor, it's only worth using native image if you can use the G1 GC that's available in Graal Enterprise. And the other question for your long-running application is like, how much do you care about throughput of the application? because even if an application is long running, it might not be very throughput sensitive. Like there's a lot of microservices that are just running very long, but in the end, they are not serving very often. They're just waiting for the next request, but they are not like really stress tested in terms of throughput. And in such cases, using native image is again much better for you because you can likely use a less expensive compute shape for running this service. So the only point where we recommend using our cheat mode is if you care a lot about throughput, meaning the CPU usage of your application is very high and it is long running. If those two questions can be answered with yes, the CPU usage is high, and yes, it is long running, then we at this stage still recommend the GraalVM cheat because it will give you better results in that scenario. But yeah, our experience talking to users is that like this is not the majority of applications and not the majority of microservices. The majority is either running not very long because it's some Lambda or function that is running, or even if it is running long, it is not throughput sensitive, so it's not actually using a lot of CPU time. And which means for the majority of cases, we already recommend now the GraalVM EOT mode and not the GraalVM cheat mode. Now, the team continues to work to improve the EOT mode because we still have, you have to understand that in both cases, it's the same compiler running. The Graal compiler is applied either in EOT mode or cheat mode, which means that about 80–90% of the compiler phases are shared. So they are run the exact same way either when you compile EOT or cheat. But there is a small fraction of 10–20% of compiler phases that are still different. And we are trying to make sure that we mitigate that in future releases. And we think that, in a few releases down the line, the ahead-of-time compile mode will also overtake the cheat mode, even for the longest running throughput applications, because there are some throughput-related optimizations that we can do better in the ahead-of-time compile mode. And the reason for that is that we can spend more time compiling, so we can do more expensive optimizations in ahead-of-time compile mode. And we have a full world view, so we can do better in terms of optimizations across methods. And for those two reasons, we think that long-term, we can also on throughput here be better. At the moment, it's still not the case that we are always better on throughput and ahead-of-time compilation, but in the future we will be. And for this, one of the things we're thinking about here is to introduce a mode where you are running native image with the extra flag that you really want to optimize for throughput, which will then take longer, but give you a better result for your max throughput.
Yeah, one thing to keep in mind is that when you're building a native image, you're essentially doing all the work that the JIT will done at runtime, right? But you're only doing this once, as opposed to n times when you deploy your app n times, right? So if you deploy your app 1,000 times, the JIT will do the same, most likely the same work 1,000 times, right? There's no potential for sharing this.
And it's funny when people make fun of the long build times of native image on Twitter, and they're like, "Oh yeah, it builds so long, it builds so long." Yeah, guess what? Like if you run this without native image, this is the CPU time you will spend on your cloud instance.
Yes, exactly.
Hidden from you, right? And it's still there. It's still there, and it will still kind of slow down your app. And if you deploy to a cloud instance that doesn't have a lot of cores, it might actually be really, really bad for you. So the JIT has big disadvantages if it has to run on an instance that doesn't have a huge number of cores. The JIT only shines if the instance you run your application on has a lot of free cores and a lot of compute power.
Alina, can you remind me it was the talk about from Josh at Spring about Spring at DevOps They talked about like squeezing a Spring native application onto the same machine, but 10 instances of one or something like that, right?
So it was like they asked the audience like how many times you have like 1 gig allocated to your JVM, right? And people said, well, a lot, right? So, and they showed the Spring native app running with like 100 megs of memory. And they said for the same memory throughput, same memory footprint, you can have 10 instances running, right? So this is a very visual way to explain how this is helpful.
Yeah, the talk is up on YouTube, so
feel free to check that out. There's also a question about the presentation as a nice native. I guess you're talking about the DevOps presentation maybe that we did, or in this thing. Does SE Standard Edition show the same results? I believe it's SE you mean running hotspot with the C2 compiler instead of with the
I would bet this is supposed to be Community Edition, but maybe Kirill can elaborate on his question. I would bet
like if by SE you mean the C2 compiler, or if you mean here GraalVM Community Edition, what do you specifically mean by SE? And the other question, yes, how does GraalVM native image relate to Project Leiden? So, I mean, there have been there's been some information about this already out there. So in general, the Leiden is a project that will that has the goal to standardize a great standard for static Java, and the native image is a potential implementation of such a standardized static Java, and native image will track whatever will end up in the Java standard in this area. Native image will track this and provide a migration path should we have to change anything substantial for existing users. And in this way, native image will be one of the implementations of the standards that are potentially developed in Project Leiden.
Yeah, the question was about community.
It was about community edition. So community edition, the throughput is worse, but the startup is still very good. So if you have, but like the break even between how many web requests at what point the chip takes over, community edition is of course here worse, which means that it's sooner that the chip will take over in terms of throughput. The community edition of native image, then it would take over the enterprise edition of native image. But in our comparison was enterprise edition chip versus enterprise edition EOT. I think if you do enterprise, community edition chip versus community edition EOT, you will end up with a very similar result. And community edition is still really awesome for startup and memory footprint. So for anything short running, using the community edition compiler, native image compiler is certainly a good choice.
So there's another comment in that direction. Can't we just cache what the compiler or what already unchanged? I'm guessing this goes into the Project Leiden bucket, right?
Yeah, I like the Freud's typo here, compiler instead of compiler. Yes,
compiler.
Is our compiler compliant? That's an interesting question. But what is meant by this question specifically?
I'm guessing the question is like, can't we just cache what the compiler is doing, so the next time you're building the app, it's much faster?
Right. Yes. Okay. Yes. So in terms of startup benefits, yes, there are approaches where you try to cache the chip compilation results. There has been also an approach explored with the Graal compiler and the concept of hotspot previously. It was called hotspot EOT. Now, the downside of this is that first, you need in this scenario to run an example application before you can cache your methods. which makes the setup more complex than if you just create an image based on static analysis. So and then the other downside is that this can only get you the benefits of startup. It cannot get you benefits with respect to memory footprint. And we think in some scenarios the better memory footprint is even the better benefit of native image, because memory is the main contributor to the money you pay for your cloud instances, and this cannot be achieved if you just cache the compiler results. We have, by the way, this type of feature for truffle languages, where we do have the ability to cache the compiler results in an auxiliary heap and then load this. And this helps us speeding up JavaScript or Ruby startup. But we think that for a language like Java, which can be efficiently ahead of time compiled, it's better to just really do the full ahead of time compilation. And in this way, then being able to avoid having to hang on to the metadata that is a big contributing factor to the memory consumption. And this is also, this is a big advantage of Java compared to something like Python or JavaScript, where ahead-of-time compilation is almost impossible because the language is so dynamic, has so many dynamic features that make it hard to analyze. Whereas Java has some limited dynamic features, but they are small enough that the static analysis still works, and that it's still possible to make Java into a language that can be very efficiently ahead of time.
Here's another comment from Lucas. Could you argue that for energy consumption reasons, native image is the far better choice? Well, most customers care about their costs on the cloud, right? You can run the same load in a smaller shape, which cuts your costs.
Saving energy consumption is a big topic, specifically here in Europe, where most of the team is. And of course, first of all, you save a lot of energy because if you an application typically started more often than it's compiled, and if you start it multiple times, you don't have to pay the energy cost of the cheat compiler cheating your application over and over again. And this is actually important when you look at the overall consumption of an application. It's not just the wall clock time or how fast it serves the requests. The metric to look for is the total CPU consumption of the application. You can see this in our latest DevOps talk that I did with Elena, where we show that specifically the native image is not just faster in terms of execution or same speed in terms of execution, but it's specifically low in terms of the CPU usage, how much CPU cycles are used to run the application. And this is a major factor contributing to the energy usage of that application. So, and it's certainly the case that if you measure the actual resource consumption, ahead of time compilation is even better than JIT compilation compared to if you just measure the workload time, the time it takes to serve the request.
I like this energy saving question. I think a few years ago, Christian Unger also had this talk how even GraalVM JIT is great for energy savings, right? Because the compiler is so much efficient, then even in JIT mode, you can see some savings just by switching to GraalVM.
Yes. If you have a long running application, it would still take a lower CPU just by running it faster.
Yeah, Phil had a problem installing the latest release. If you can tell us the operating system and architecture that you're using, we can look into it. But we've just rolled out the release, so bear with us, and it will also be available on SDKman very soon. Yes, shall we continue?
Yes, we are almost 1 hour in. We are barely done with the native image and compiler part. So let's see what else is there.
This is good. Keep the questions coming.
Yes, we love the questions, so keep them coming. So moving on, another exciting update we want to talk about is our Python implementation. So as you know, we have Python implementation on GraalVM that we used to call GraalVM Python, and now it's GraalPy. So the project has a new name, and we also renamed the launcher. And we believe that this name, GraalPy, is not only shorter, but it's also very nicely aligned with the Python ecosystem and how things are typically named there. So let us know how you like this new name. We like it a lot. And also we have some links for Python and Python 3 for GraalPy, so it's easier to use it from various Python IDEs and tools. And another great update from GraalPy is that Flask now works on GraalPy. So that is a web framework that gives you some typical features such as development server, debugger, support for testing. It can be extended with various extensions and more. And here is a preview of it, but also I believe that we have a demo that we can show you live, right, Fabio?
Yes, let me go and share my screen. Lucas is already asking about AOT and Truffle. We may be able to answer that at the same time. So what you're seeing here is PyCharm, the Python IDE coming from JetBrains. And we're looking at the Python 3 file in my venv directory. So what I've done is I've created a virtual environment within this new project. It's a Flask project because we want to show Flask here, right? So I've created a new venv from within GraalPy, and that has created new symlinks for Python and Python 3. So this is indeed pointing to my GraalVM or GraalVM installation. In this case, I'm using Community Edition. And this sets up a few paths, but you don't really have to worry about that. So that is all done automatically, and I selected essentially like an existing venv in here. We want to make this even easier, so you can create new virtual environments from within PyCharm, but this is just the beginning. So in the application, I have already extended the application a little bit with PyGuy, which is a plotting library that can plot something. And so essentially the app has one endpoint, just slash, and it can present some charts, right? So this app is using Flask and it's using PyGuy. And PyCharm has this cool Python packages tab here on the bottom. So we can see what is already installed. So I've already installed PyGuy, the plotting library, and I also installed Flask. Right, so you can see all of this from within here, and I can even like delete the package from within here. So I can manage my virtual environment from within here, including all the dependencies. So Flask depends on some other things, but you may have noticed there's also things like HPy, which you may have seen on our blog post, a new C API that we are working on for Python. So, and also I can just go here and say something like numpy, but numpy, and then I could install numpy here if I want to use this. But I've already installed the dependencies for this application. So the other thing that you may notice here is I also set a breakpoint here. So, and what I can do is I can run the whole app, of course, as usual, but I can also run it in debug mode. And here we go. So this is a Flask app, and it's using the PyCharm pydevd utility, I guess, to connect the pydev debugger. So, something didn't work, I guess. Maybe I'm still running some other server. Let's see. Maybe it still comes up. I haven't seen this before. Or I'll just retry. Let me retry. Oh, there it is. There it was. Okay, so we're running the debugger. And I think I may already be running some other PyCharm in here. Yeah, let's see. Let me quit all those processes. Okay, so something is up with my machine. Let's try again, one more time. Yep, this is expected. We're working on proper thread sampling. So, and eventually this should come up. So now the server is up. For some reason it didn't work. I guess I was running it before already on my machine. And now I can go and open this in a browser. And when I do this, I actually end up here in the breakpoint. So the browser is now waiting for the result. I'm going to show you what that looks like in just a bit. And of course, we can step over things, and we can look at frames, and we can look at the object here as you normally would, right? So debugging works, and that was a lot of work because we needed to make sure that the Python debugging infrastructure works with Truffle. And that is now the case. So if I resume, the request is actually being served, and I can see the result in my browser. And this is what it looks like. It's a little chart, a little bar chart. And what we see here is actually the time it takes to import Pygarn, the plotting library in Python, comparing the 22.2 release with the 22.3 release. So, and in this release, in the last release, GraalPy was still using an AST interpreter. So, and here it took around 7 seconds to import just Pygarn. But in that release, we already introduced a new bytecode interpreter that we've been working on. And that is now the new default. And with that change, we have almost cut the time to load Pygarn in half. So now it takes 4.5 seconds roughly to import the same library. I think that this is showing that we're still making a lot of progress in terms of performance and compatibility. We want GraalPy to work in your Python IDEs. So PyCharm here. Next time we focus also on VS Code. We've been focusing on VS Code Python before, but yeah, I wanted to show PyCharm here today. And so you can expect more updates from our Python team very soon. And I think that's all I wanted to show.
Thank you so much, Fabio.
There's more questions. So let's see. I forgot. Of course, I would be able to connect the instance, the server, with GraalVM and show it in there, and then I could have shown you that I was actually using the AOT version of GraalPy. So we can AOT compile all our languages, and we can even persist some of the guest language compiled code in a cache, which we call auxiliary image caching. That's something that we can do. There's a lot of AOT going on in Truffle. I wonder, what about interoperation? That's a good question. Well, you can certainly build a shared library and use that in your Java embedding. That is another scenario that we support. And of course, you can compile the whole Java application, including one of our language interpreters, into one big binary. We have blog posts on this up on our Medium, I think. So what else is there? When is M1 support? Well, M1 is already supported. And that is also true for M2, I guess. So we are adding more components to M1, but most of our components are already on M1. Yeah, Alina, you already answered that, right?
Yep.
Yes.
Good.
And I also give some links related to Truffle ERT in the chat if anybody's interested.
Perfect.
We have Truffle ERT, but it's more of the snapshotting kind. It's not a closed world analysis ERT, which means it can improve startup. It cannot improve memory footprint. And yes, there's another very important question. Where can I get a Duke with a helmet? Yeah, Alina, I guess that's for you. Where did you steal this one from?
This cute Duke is coming from the awesome Java Zone conference. I guess it's supposed to be a Viking because it's in Norway, Oslo. So I recommend the next year you go there and you get one of those yourselves. But also thank you for noticing. I like it a lot.
Absolutely. Cool. And speaking of cute mascots, etc., right?
Yeah.
But I'm giving you a teaser. Yeah, so stay with us.
So we're not doing just one more thing? Okay, we're not doing it. Okay.
This is taking time, but this is an important teaser. We have a nice update for you in the end. So bear with us, and we will get to it in a few minutes, I hope. Yeah, so we were talking about GraalVM and a few more updates there. So as always, we are trying to ensure that we have great compatibility for our GraalVM. And in this release in particular, we implemented new parser and we added support of a couple of new APIs. So this will help us implement the AST module as well as PDB and profile packages for GraalVM. And also we updated pip in a way that will automatically choose the best version for known packages. So for example, when you are running pip install pandas, it will pick up the best version of pandas and numpy that are tested in our CIs. And also, yeah, as Fabio said, the new bytecode interpreter is now enabled by default, and you can see how much improvement it makes in terms of performance. So that is that, and we're a bit over time, I think, so let's speed up. Another update is that we now have GraalVM LVM runtime on Windows for Community Edition. So this is great on its own, but also it will help us bring more GraalVM languages. So for example, GraalPy and other languages on Windows as a platform as well. So expect more updates for this in upcoming releases. In terms of loaded embedding, we added ability for a context to spawn inner context that can modify and override language options. And also Ruby has a lot of new features and compatibility and performance improvements. You can read more about it in the changelog. And we want to briefly talk about some of the community updates. So this is from the
big updates.
Yes, some big updates from the community. So one is that Spring Boot team released the Spring Boot 3 RC1. You can go and read more about it and get started with it here. The important update is that it has a lot of AUT and native support updates included in this release, so please give it a try. And you can read about it, or also we are linking to their recent presentation, again from Davos, Belgium. So that is also a way to find out what is the status of IoT and native in Spring Framework and Spring Boot. Also, Micronaut introduced this new test resources feature that allows you to easily test against external dependencies. And one of the ways you can do so is by leveraging test containers. And Micronaut just makes this so much easier to do test resources. So that is that. And the Quarkus team published this nice, very extensive guide on getting started with Quarkus and native image in particular. So give it a try if you haven't tried Quarkus yet. And the Hackathon team, we briefly mentioned before that various teams and specifically framework teams are adopting virtual threads. So the Hackathon team published this Hackathon NEMA announcement, and they show some very nice results for running using virtual thread here. So this is Hackathon SE, and this is Hackathon NEMA leveraging virtual threads. There is that. Also, we, IntelliJ IDEA added experimental support for debugging native executables produced by native image, and JUnit framework added annotations to include or exclude testing native executables with native image. And also our community did this fun project where they compiled a Minecraft server to native. So you can read more about it in this guest blog post that we have on Medium. That is community updates. And to move on with this community section, we also want to acknowledge some of the community contributions. So I think Fabio already mentioned how we are working with Red Hat to extend our JFR event support and improve debugging in native image. But also we are grateful to the IntelliJ team who provided some helpful feedback for us to improve debugging of native executables on native image and IntelliJ IDEA specifically. And also we showed you before our GraalVM reachability and native build tools repos. So we are working on those with the Spring Boot and Micronaut teams, and we are grateful for their contributions as well. And Shopify helped us migrate Truffle Ruby to Truffle String. So thanks for that. And with that, I don't think I have any more questions. And this is the promised announcement. So please meet Rabbits. It's our new mess. And in fact, it's not a rabbit, it's a hare that is supposed to be faster, stronger, and all those things. But we just love the name Grabbit, which Fabio came up with. And I think it's brilliant. So thank you, Fabio, for that. So we now have this cool mascot, and very soon we will have on the website a page where you can get this mascot image, but also logos in case you want to do any blog posts or conference or meetup talks about GraalVM. So we will share all those assets with you. So let us know
I
how.
guess now the pressure is on that you have cool swag at the next conferences.
Yes. So expect more cool swag as well, and let us know how you like it. And that's pretty much it. And I don't see any questions. Thomas, Fabio, do you have anything else to say?
That's cool. Excellent. Yes, I'd like to thank everybody for listening and giving us good questions in this release stream, which has been, again, interactive. And this is the way we like to do this. We like to talk to the community, so you can give us feedback. Thanks, Alena and Fabio, for excellent presentations in this release stream. And with this, yes, thanks everybody, and see you at the next release, latest.
Thanks everyone. Bye.
Bye.